In this video, we will use series sum to generate the function expansion of the Google Sheets ERF function, which is also known as the integral of Gauss Error Function, and using Taylor Maclaurin series using series sum. And we'll also regress it using the LINEST Polynomial Regression to the 8th degree. So let's generate the error function over their values of x from -2 to +2. So array formula, the error function, Gauss error function of the x values. And we have the trend line, which is regressed to the 8th degree. So we have b0, the regression coefficient is b0, which is 0, b1, b2, b3, b4, b5, b6, b7, and b8. We'll calculate this using LINEST. Next, we enter the expansion, the approximation of this ERF function, the Taylor Maclaurin Series Expansion, which is equal to 2 over square root of pi times the summation of coefficient times x to the power 2n plus 1. The coefficient is -1 to the power n over n factorial times 2n plus 1. The values of n will start from 0 to infinity. In this case, we'll just get to the maximum of our dataset. Now we generate the coefficient. We start with the numerator, which is array formula, factorial of the n values. Now that we have the n factorial, let's add the second part of the denominator. So that is 1 over. Oh, this one. Then we complete the denominator. That's 2n plus 1. 2 times n plus 1. Next, we add the numerator, which is -1 to the power n. So that's -1 to the power n. And that's more correct. Now that we have the coefficients completed, we continue. This time we'll use series sum. This array formula, series sum of the x values raised to the power 2n plus 1. So in this case, the power starts from 0. That's 2 times 0 plus 1. So starts from 1. Incremented by the next one is 1. So 2 times 1 equals 2 plus 1 is 3. So the difference is 2. So that is x to the power 1 incremented by 2. And the coefficients. We're almost there. We're missing the 2 over square root of pi. So we're going to multiply 2 over square root of pi. That's 2 over square root of pi. No. And the regression coefficients are almost the same. So B0 and B are the same. B1, 1.12. B2, 0. B3, 0.353. Negative 0.353, negative 0.348. B4, 0. B5, 0.0786. This one is 0.0732. So B0, B6 is 0. B7 is negative 7.38, exponent negative 3. This one is negative 0.583. They kind of be different as the exponent goes higher, but they are smaller. Next, we will calculate this coefficients using LINEST. To do that, we will generate the 1 comma x matrix. So here we have the 1 comma x matrix. We start with the 1 column, the x column, and the x squared column, and so on. So to get the power, we use transpose of the x values. Now we can calculate the x to the power 1. So this is equal to array formula of the x values to the power 0. That's the 1 column. And we lock the references. And we drag this to fill up the complete 1 comma x matrix. So that's the x column. This one is the x column. Next, the x squared column. And the x to the cube column. X to the fourth column. X to the fifth column. X to the sixth column. X to the seventh column. And x to the eighth column. We'll be using this later in the next video. We will have the estimated y, or the y hat. And in this case, we just limit to the LINEST without the full statistics. So we use LINEST on the error function. LINEST of the error function and the x values. You will notice B0 is 0, B1 is 1.244, 1.1244, and it is 1.12. B2 is 0, B3 negative 0.3529, negative 0.353. B4 is 0, B5 is negative 0.078, or positive 0.078, 786. B6 is 0, and B7 is, this should be in the scientific form. That's 7.38 times 10 to the minus 3. So that's for the LINEST of the error function. Now we go to LINEST of the expansion. So LINEST of the y values and the x values. You'll notice there we have the same value of 0, almost the same values of B1, almost the same values of B3, same values, but this will be a little different. So we will have different values in B7 and the higher degree, but these are smaller values. So this completes the LINEST Polynomial Regression of the Taylor Maclaurin Series Expansion for ERF, Google Sheet ERF function, the integral Gauss Error Function.